Shafts are used in many machines to transmit power through gears or pulleys. The rotary motion and torque are transmitted to the gear or pulley through a key. The proper size and fit of the key are critical for the proper functioning. In this video, I'll introduce the common key types, sizes, and usage. The standard key types as shown here are square keys, flat keys or rectangular keys, Woodruff keys, dowel pin keys, Pratt and Whitney keys, which are also known as feathered keys, tapered keys, and gib head keys. It's also a tapered key. The material selected for a key should have the same strength and hardness as the shaft or hub, unless the key is being designed to be the point of failure. Key failure is due to bearing stress or direct shearing. The key length should be designed to a desired safety factor which is not too excessive. This will ensure the inexpensive key is the weak link. The length of a key is limited by the hub length of the component attached to the shaft, and it should not exceed 1.5 times the shaft diameter to avoid twisting. Multiple keys can be used for larger torque requirements. They should have a tight sliding fit with a small radial clearance above the key. Too much clearance will cause maintenance issues and can lead to machine failure. When using a parallel key, the shaft is typically slotted for its entire length or from the end of the shaft to pass where the key will be used. Square keys are general purpose keys typically used in shafts from 1/4 to 1 inch in diameter, but can be used in larger shafts up to 6.5 inches. They are used when a rectangular key will not provide enough strength. Rectangular or flat keys, as they are also known, are general purpose keys typically used in shafts from 1 to 20 inches in diameter. These keys are larger in their width than their height. This larger width allows for greater torque transmission without increasing the slot depth. Typically, the key width is approximately 1/4 of the shaft diameter. For shafts larger than 11 inches, a key seat is typically not milled into the shaft. Instead, a flat is milled, while the mounted component still has a broached keyway. Set screws are often added to prevent movement of the key in the shaft. As a general rule, the length of engagement of the key into the gear or pulley is equal to 1/2 of the key width. Parallel keys should be used where a unidirectional torque is to be transmitted and there is not a heavy starting load, as well as when periodic withdrawal or sliding of the gear or pulley is required over the key. The size of the key is based on the shaft size, and this chart shows the nominal sizes of parallel keys as well as the keyway depth based on the shaft diameter. For standard inch keys, this chart shows some of the parallel key sizes to be used for metric shafts ranging from 6 to 75 millimeters in diameter and the keyway minimum depths. Woodruff keys are half round and can be purchased with or without a flap. These keys have deeper penetration into the shaft, which makes them useful for smaller diameter shafts to prevent the key from rolling. They also tend to have a lesser shear strength than the rectangular or square keys because of their shorter length. When a Woodruff key is used near a shoulder, the stress concentration interferes less with the shoulder than a parallel key. Woodruff keys have the advantage over parallel keys in that once they are properly installed, they cannot move out of the hub along the shaft. They are typically used on shafts from 1/4 to 2.5 inches in diameter. Woodruff keys are not suited for use when a heavy torque is transmitted, such as with a wide face gear or a multi-grooved belt pulley. They are well suited for low torque applications or mounting of tapered bored hubs onto a tapered shaft. Woodruff key diameters typically equal the shaft diameter in which they are used. For inch Woodruff keys, the last two numbers of the key equal the nominal diameter in 1/8 of an inch. The 1 or 2 numbers preceding these are the width of the key in 30/2 of an inch. This chart shows the Woodruff key number to use based on the shaft diameter. And this chart shows the key width, diameter, and depth for some Woodruff keys. Dowel pins or spring pins are often used as a key on a 1/4 inch or smaller diameter shaft. When using a pin as a key, the hole can be drilled into both components while they are assembled, or a ball nose end mill used to make the key seat, and a slot broached into the hub which will engage the pin. Pratt and Whitney, or feather keys as they're sometimes called, are used for shafts 1/4 to 2.5 inches in diameter. While being able to withstand the same torque as square and rectangular parallel keys, since they are rounded on both ends and the slot in the shaft is cut to the key length, they have the added benefit of not being able to slide in the shaft, and no set screw is required to hold the key in place. Taper keys are used when large unidirectional, reversing, or vibrating torques are present and when occasional withdrawal of the key may be required. The gib head makes the removal of the key easier than a standard tapered key. These keys have an 1/8 of an inch taper per foot, and by tapping them into the keyway, the taper helps secure the hub to the shaft. This wedge helps to minimize the chance of the key from vibrating out of the assembly. Gib head keys come in lengths 4 to 16 times their width.